We have installed a Discovery hybrid rheometer here today, which is going to be used as both a rheometer for shear testing and dynamic mechanical analyzer. The installation consists of few main parts. It's an instrument itself with environmental test chamber for temperature control, compressed air cooler, electronics for the instrument, and a computer. To operate the cooler, you need to make sure that we have compressed air connected to the system and running at the pressure between 90 and 100 psi. The valve should be in this position. You have to have the cable, this cable, connected to the gas box, and when it's all set up, there is a power button here. You switch it on. This little display will read your temperature, and when you switch the power on, the system goes through the cooling process of 3 different stages. So it will take about 45 to 60 minutes before you can read somewhere around minus 100, 110 degrees C there, and the cooling air starts to flow through if your oven is closed and if your set point temperature is below ambient. So to start working, you set your temperature, say, to 10 degrees C or 0 degrees C, close the oven, switch everything on, and you wait until the system is ready. And when it is ready, you should see this little white ball jumping up, meaning that your cold air started to flow through the furnace and your temperature starts dropping down. So from this point on, your cooler is fully operational. To switch it off, first thing you do, you turn the power off, but you leave air going, because at this time it will flash the system while it's warming up with air, compressed air connected there. It's a good practice at this point also to close the oven and set up your temperature to 10 degrees C. So what it means is it will allow your gas go through the system, through the oven, and flush out any moisture which is accumulated there. Sometimes you will need to do it overnight to make sure there is no moisture sits inside of your cooling system, and indication of excessive moisture or frost build is that your flow here, when system is ready, is not going to be as high as it used to be. So that would be an indication that you have to leave it running overnight, making sure that you get rid of all moisture inside. So the main part of the instrument is an air bearing with a motor, which is at the same time applying force and measuring a displacement. When you start your operation with an instrument, the most important part is correct air supply. So you have a pressure regulator here, which has to be set up at 30 psi before you touch the instrument. So after you verify the pressure on this regulator, which is going to be mounted later on a bench, the next step you remove the protective cup. The right way to do it is to hold the cup and unscrew the screw at the top. After that, we're ready to switch electronics on, and when everything is working fine, you should see this shaft raising up and starting to spin, like that. Okay, so that's an indication of all correct operations, and then you will see your signals, and if everything's working fine, you should not see any errors. Now your oven is a two-door system, and then at the bottom or top we're going to install different geometries depending on type of tests we would like to perform. This instrument is equipped with 4 different types of measuring system. One which is called parallel plate measuring system, the bottom part and the top part, like that. Plates are installed here and here. Another one is tension measuring system, when you have bottom part and top part and you insert your sample between those. Then you have what we call clamp bending system. The bottom part is installed here, top part will be installed here, and you can do dynamic mechanical testing like that. And another one is a torsion system. This is your bottom part, and top part is installed at the top, and your sample is deformed this way. Okay? In addition to that, we have a cooler which will allow you to test your samples from the temperature minus 100 degrees C and with a furnace up to 500 degrees C. You do not have to use cooler if you work at above room temperature. So this is only optional if you need to achieve subambient temperature. I'm going to show you how to change geometries here, which is very simple on this instrument. So to replace bottom part, what you do, you press this button here once. You should see green line blinking. You disconnect the plug, press it second time, you can remove it. So there is a magnet here which would release this plate, and then install it back. You just put it into the slot and connect red dot to red spot, like that. Instrument is smart enough to recognize which geometry you install in, so it will be recognized there. Top part is done similar to how you put and remove protective cup. So you insert it like that, hold it here, and you screw in the screw. Very simple. Also on this touchpad you can move instrument head down or up. One little trick here, if your doors are not fully open, it will not allow it to move up, but it will allow it to move down. Fully open, there are switches at the end, you can move up. Okay. To operate cooler, you need to make sure that incoming pressure of the air is between 90 and 100 psi, as shown here. The valve is open, and then you just press this start button on the side. And for this cooler, it will take about 45 to 60 minutes to get up to the level of minus 100 degrees C. So the way it's designed, it will not start pushing cold air through until it's fully operational. So you switch it on, you wait until it's done, and then you will see cooling starts. Also with this system, when the doors are open, it will not heat or cool. So the only way to operate temperature, you need to close the doors. And now you can hear and clicks. That's air going through, purging and stuff like that. So it's operational now. Okay, now I am going to install a parallel plate accessory, and we're going to look at the software, how to operate it and what to do with it. So I'm going to raise the head. Remove this part. Remove this part. Pin in a slot. Red to the red. You have two types of plates. One with a drip channel. This one goes to the bottom. And this one goes to the top. Okay, and now I'm ready to set up geometry in my software. The instrument is operated by the software called Trios. To connect to the instrument, you double click on this icon. When connection is established, you should see green circle around the instrument picture. Click Connect. So typically when you install your geometry already, you should go to Geometries and make sure that your green check mark is shown next to your current geometry type. If not, you go here. Oops, sorry. You go here and choose the geometry which you're working with. These parameters are usually default values, and you don't change anything here during setup. You can go to calibrations, and you can calibrate it if you want to, but you don't have to because this is all stored within your file. But from this moment on, you're ready to perform your experiments. Before you do, you have to do zero gap. To do zero gap, you click on this tab. With these buttons, you can bring head down. So I'm going to bring it together within around 5 mil. And then I press the button which is called zero gap. Instrument will find the zero position. And when it's done, you get this message on the software. Head zero completed. Do you want to raise the head to the lodging gap? You say yes or no, depending on what you want to do. Now you can perform the same operation using zero gap button on the instrument. The only difference is it will not give you this message which we saw before. So if I go down now, and press zero gap, typically it would go then back to 100 microns and just sit there. So your gap is done. But no message. So that's the difference between those two. Okay, from this moment on, your instrument is ready to perform tests. Sometimes, depending on what you do, you would like to bring your temperature to a certain level. So you would close the oven. And you would go to Environmental tab, and you put your set point temperature. For example, 40 degrees. Apply. So what is going on now? You have set point temperature 40, and you should see your temperature reading starting to increase. And it does go up. And it will bring it to 40 degrees C when you close the doors of the furnace. So depending what type of experiment you do, you can preheat your oven, then you open the furnace, then you can do zero gap at the temperature. You can load sample at elevated temperature. So that allows you to do this. If you want to use cooler, you can do similar thing with the cooler. When instrument is conditioned with temperature and zero gap is performed at the temperature, you can do experimental setup. In this page, you have to fill in sample information. Geometry is set up by default, and then you set up your experiment. So typically, you would choose first step as a conditioning step. When you bring your sample to a temperature and hold it there for some time, and then you add an experimental step. In this case is oscillation, and typically you would do temperature sweep, temperature ramp. When you increase your temperature, while oscillating at certain strain and at certain frequency. With this particular accessory, one of the main tests will be studying of curing of epoxy, for example. So for tests of this kind, you might start your experiment at low temperature, usually at room temperature, say 30 degrees C. So your first step would be conditioning, sample, temperature, 30 degrees C, and you wait there for 2 minutes. Then you add next step. And typically oscillation step will be done as a temperature ramp. So you increase your temperature while you're oscillating and looking at viscoelastic properties of your epoxy. When epoxy starts hardening, you will see sharp rise in G prime and G double prime. So start temperature 25, end temperature, say 200 degrees C, ramp rate 5 degrees C per minute. You may use slower rate. And you do it at certain strain. So for epoxy, something like 0.5% perhaps. And constant temperature. It's frequency 1 Hertz, constant frequency, sorry, 1 Hertz. So when you set up your experiment, you load the sample, you're ready to start with this green button. When experiment starts, it will open up results file and you will see your graph building up as experiment goes. At the end of the run, you can open the furnace and raise the head and clean your plates and so on. Okay, so you do typical preparations when you run DMA tests. It's all very well described in help files. Help files are held here on your computer. Trio's online help. DHR. Typically you can put what you're looking for, bending, search, clamp bending geometry, which we have. It gives you very good information how to set it up and how to perform the test. So I suggest this is the best way to start on something new and use it to your advantage. Okay, now I'm going to show how to shut down the system so that it's all done properly. So you wait typically until your temperature is at room temperature. You open geometry. You go up as much as you can. Remove the top part. Close the furnace. Switch software off. Switch electronics off. Install the cup. Okay, from this moment on you can turn your air supply off.